the world harness opportunity, overcome challenges, and achieve outsized outcomes. AlixPartners, when it really matters. And by Bridgestone Tires, solutions for your journey.
Hey everybody, thanks for joining us on Autoline After Hours. Gary Vasilash is out right now. He's out in Nashville, actually. He went to go see a concert. We lost out to Joe Jackson, but we've got Joe White in his place.
Almost as good.
Yeah.
Can't play the piano, but other than that.
You can play the guitar, though.
I can play the guitar. I think probably Joe Jackson can, too.
So, and Joe, right now you're doing
I have a Substack high-speed Rodeo, and I'm also doing a podcast with Tu Lee called At the Wheel.
Yeah. Formerly Wall Street Journal, formerly Reuters, bunch of stuff, just so the audience knows. I know you already know that.
Right.
And we got Steve Plumb joining us, too. Mm-hmm. Steve is the editor-in-chief, I guess I should add, of Manufacturing, Engineering, and Technology. I want to say magazines, Steve, but we don't really do magazines anymore so much.
Actually, we do.
You do? You've got a print version?
Print is still very popular with
awesome. I love it.
We also have a website at advancedmanufacturing.org.
Right, right. That I knew.
And Joe, I have to admit, you do look sharp to continue the Joe Jackson theme there.
Thank you. All right.
And I got to let everybody know we've got Del Costy. He's the president and managing director for Siemens Digital Industries for the Americas, with a great automotive background, history of it too. And Del, I'm so glad that you're able to be with us. Later in the show, we're going to have Mark Wakefield from AlixPartners. But let's talk digital industries, digital technologies. Yeah. So I'll kick it off and then you guys jump in. But speed to market, China speed, is what everybody is talking about so much in the industry these days. And one of the key ways of achieving that, of course, is simulation. And I got to believe this is one of the things that Siemens is deeply into.
Oh, gosh, I think it's the foundation of everything we do. So we often talk about digital twin, and people have a different representation of digital twin. You'll hear a lot of people talk about it, and they think about it as a sophisticated 3D CAD model, but it's just so much more than that. And it's really important to set that up before even getting into the simulation, because when we represent the digital twin correctly, it's a multifaceted, multi-physics, multi-function model. And so it's going to represent your engineering domain. It's going to represent your flow down of your requirements, your system model thinking in this 3D geometry. And it also can represent how you produce the product. Mm-hmm. And so this connected set of capabilities, when it's there and it's there properly, what you can do with simulation is absolutely outstanding. And that's where we see, I think, some of the key advancements to drive NPI cycles. And so, yeah, it's a highly important area. And I think you guys saw we spent a couple of bucks on an acquisition not that long ago of a company based in Troy, Altair. And that's been a huge, huge benefit to the overall portfolio.
I don't know if it was part of the Altair purchase, but I think I saw that a recent EV development program brought to market in 22 months.
Yeah, we even showcased that we were talking about Realize Live earlier, our user event in Detroit. And so we had over 3,000 people. And we have a Techcellence Award. And so we did, Lucid was one of the nominees. They did some really amazing work in compressing their vehicle development cycle and eliminating a significant amount of physical prototypes. And so that's the ability you can do. And, when you think about simulation now, in the past, you would do a prototype to discover issues. That's not really the case now. If I'm going to do a prototype, I've already discovered the bulk of my issues through simulation and through the comprehensive digital twin. And so bringing all that rich data to this digital world, I can go through all these scenarios. And now when you look at AI on top of this, it's no longer spend a lot of time building up a model, analyzing that model, and going through a few iterations. With AI. I can experiment with thousands of iterations digitally.
So you've hit on something that I wanted to ask you. Is sort of position your technology, the simulation technology, against AI, because you hear automakers, and I call it heavy metal AI. I mean, they're talking about we're actually going to build something physical at the end of this, not an LLM. But how do you use your technology relate to the AI that the automakers are getting from companies like Oracle or blanking on the name of it? It's never mind. Other AI providers.
Yes.
Yeah, this we could take the whole discussion on this alone. I did a talk at Reindustrialize last week, as a matter of fact, and the thesis of the conversation is we have a lot of probabilistic models. And if we think about OEMs all over the world, this is what they're wrestling with. How do I incorporate? Every executive's getting so much pressure on AI. And so companies are running fast. Companies have spent a tremendous amount of money. And you guys can read all the publications. How many have really seen the value?
That's exactly my question.
That's the genesis of the question, 100%. But the fact is we live in a very precision-based world. We have people in these vehicles. These vehicles interact on the roads like we discussed earlier. Precision matters. And so probabilistic models have a place. And what I would say is that the thing I discussed at Reindustrialize is imagine a design of experiment, highly accelerated. So I can go through thousands of iterations. I can interact with a model. Give me this scenario, give me this scenario. Go back and look at what's been done before, bring that forward. Let's experiment with that. But I can still put simulation at the core. Math matters. We have one of the most robust, widely used math kernels in the industry, hands down, with Parasolid. And this math engine matters. And it's highly performant. You couple that with systems model thinking, AI accelerated, and validation in the loop. Now the engineer can go through multitude of iterations faster than ever before in the digital world and hone in on really, really good answers. So AI doesn't have to be the holy grail. It's a facilitator of amazing ideas. And I still have engineering in the loop. I'm accentuating the power of the engineer in essence.
And by the way, Palantir is a company I was struggling with just before. More coffee, please. I'm curious because I've been hearing about digital twins and simulation for a long time. Probably not as long as Steve has, but a long time. But I'm wondering, what's kind of the rate of adoption now? I mean, how pervasive and mainstream is this tech? And if it isn't, how fast do you think it will become pervasive and mainstream, given the competitive issues that John raised?
Will be, has to be, I think, is the context we have to discuss, candidly. In automotive, there's some great, where automotive was pioneering digital go back 30 plus years ago. I remember the first engagement I had, the precursor to Siemens was UGS, Unigraphics. I was working with Visteon shortly after it spun out of Ford and working with the manufacturing engineering. That's where it started for me. And me and this gentleman were going through and looking at, so you were a tier one back in the day. What did you have to do? You bid on work. And so you were given expected volume of the particular program you're bidding on. And then you would say, okay, well, here's my bid. And then you get a task to target if you won. So now you had to figure out how to drive cost out. The issue was because of the way the tools were implemented, we were digital back then, but they were disparate digital tools, not necessarily connected, serial in nature. And so we would do all this development work in the vehicle development process. We would get to a certain gate, and then manufacturing got involved. Then if you looked at, and we mapped out all the great manufacturing tools that would get involved, well, just about all of them were put in after design freeze. So your ability to change is significantly reduced at that point. After design freeze, your cost to change is very high. So we looked at the intersection of the curve. We said, if we could front end load, we came up with the concept, if we could shift everything left and bring it much earlier in the design cycle and start doing our manufacturing capability digitally, then all of a sudden we could discover these issues. We could get to the task to target cost, and we could figure out how to drive cost out through the life of the vehicle program. And that was a light bulb moment. And this was 25 years ago. Mm-hmm. We're still making progress today. But if you fast forward and compare to the Palantirs of the world, great company, huge market cap. But it's interesting. What are they doing? They're mapping out your ontology. And for the viewers, it's basically, how do these communication protocols, how are they going to happen amongst all these data types? But you have to figure out how you're going to do that, because if you, in essence, lock in your systems, how do you upgrade? I need to upgrade technology. And so what we're working on, and we at our customer event talked about this, the concept of Intelligence Center X, and I think it's key. Again, part of Altair and another acquisition we had done years earlier. We're looking at this completely through a different lens. If I can contextualize the data across the life cycle, and I can link these data types, and so imagine I'm getting a warranty issue. A warranty isn't an issue in isolation. I quickly need to figure out what happened with my production runs. Is there something I need to discover out of manufacturing? Was it a product design issue? Did I have a requirement not met in the way I produced or designed? Connecting these systems and developing my ontology on the fly, now I can do pretty amazing things and get access by AI to all those different data that are sitting out there that can help me diagnose that problem much quicker than ever before. This is the promise of what we can do. Now, I'm still going to be the one sitting here saying, I still want deterministic models in our world. I want to know if I ask that same question 6 different times, I get the same answer 6 different times. And that's not often the case with generic AI. It's not the case with generic AI models. So I think that's the line we have to walk here in our industry.
Okay. Yeah. You can't have hallucinations.
No.
Yeah. Del, you mentioned how Lucid was able to compress this. They're doing amazing things. I happen to think that Rivian's doing some really impressive stuff. Tesla was the one that was blazing the way, but they're all startups. And I know the legacy automakers are working on all this, but they all seem to be struggling with it, especially when you get to a software-defined vehicle. What are some of the advice that you would give to legacy automakers and suppliers, by the way, too, of how they can accelerate this? Because the benefits you're talking about are exactly what the industry needs.
John, I honestly think we're going to see some major acceleration. And we're working with just about every one of the companies, the legacy, the startups, on each continent. And so we are seeing amazing work. This is not a lack of effort. The companies are doing incredible things, but you got to understand, these are companies that are mid-flight in a lot of programs. They're producing vehicles, they're servicing vehicles. This is not necessarily the easiest challenge, but the progress is being made, and we're seeing companies experimenting with some really exciting ideas. But we also look at it, and we look at the maturation of the bill of materials. So we have a design BOM, an electronic bill of materials, and a manufacturing bill of materials, our electronic bill of process. How do we make sure we're connecting all those things? And we also have to look at mechanical engineering, electrical engineering, electronics, software combined in a systems model. By having these foundations connected and making sure they're connected, this is where AI can accelerate what we do in vehicle development. So this is all about gaining insights faster than ever before. I would tell you it's the transition from current state. We talked about at Reindustrialize. You're seeing all kinds of countries do amazing things with manufacturing, and now there's all this investment in the U.S. What's it going to take for us to get over the hump? The fact is, we have an extremely rich heritage, no more rich than right here in Detroit. I tell everyone about Freedom Forge, the book. It's an amazing book. It's an amazing read. But it showed the power and impact Detroit had on U.S. manufacturing. I think we have that opportunity again. But the fact is, we have brownfield. So it's the same issue in manufacturing as we see in the OEMs you're talking about. We have to take the existing structure and start evolving it quickly. I think it takes to be really well thought out in how we're applying these technologies to what we have today. But yeah, there are advancements that we talked about. How do we link these different functional models, accelerate with AI, and then make sure we're having this simulation at the loop? This is what's going to put this, we call it comprehensive digital twin, but that's what's going to put it in flight and in motion. And these are just initiatives that are really in flight everywhere, by the way. And so this is not a lack of effort of any of the OEMs.
You mentioned engineering in the loop. Workforce is a key issue throughout manufacturing in the auto industry. How are engineers interacting with AI now? What kind of training is being done, and what's being done on the college level to prepare the next generation for this?
There's a lot of work to be done there. There's no question about it. I think a lot of college campuses are figuring this out right now. But candidly, Steve, AI done right, there shouldn't be a huge lift on the training portion of it. You need to interact with the models that you have and the systems that you have. I think the balancing act is every company like ours, we're building amazing AI capabilities in our offerings. It's how you connect the offerings to get the insight. The shop floor worker, a little different. That is where I think we need to put a concerted effort. And so we're having a lot of conversations in that area. What do we need to do for tool facilitation or learning aid facilitation? But it starts with that foundation level. We've launched this thing called micro-credentialing that will allow students to get in there early. We want to get it as early in the curriculum as possible to understand the concept of engineering, and then how is AI an enabler for that. But the AI should be incorporated right into those sessions. As simple as we had the complexity of CAD environments, a designer or an engineer working in CAD. AI can study their behavior model and help recommend, based on the way you work in the tool and the type of work you're doing, here are the commands that are coming next for you. Still want the human in the loop, so they're controlling that session. But these are the little things we can do to embed AI in what we're doing every day, but still put the worker in some form of control. Like, you still need to be involved in that session.
So Del, can you talk a little bit about, you mentioned on the shop floor that people would actually need more training than some other people in some other parts of an organization. Can you go a little deeper on that? I mean, how so? I mean, what would you need? What's going to be the difference between a production floor employee's job in an environment that's got your technology fully plugged in versus today?
Yeah, this is one that's it's kind of fun to follow what's going to happen, and you hear two schools of camps. You hear that AI is going to accentuate the job, and then you also hear a lot of discussion on lights out factories. The reality is, I think the companies of the future that are going to be hyper successful are the ones that are going to be able to gain insights quickly, and this has an implication how you produce product. And so if I can gain insights quickly and I need to modify quickly, how do I translate that to how I'm going to build product? Where am I going to build product? How am I going to handle supplier resilience? And what's the implication on the shop floor? We refer to that as adaptive. I want, and we go right to this idea of lights out. I go right to the idea of adaptive. How are you going to be flexible with what you produce, where you produce, how you produce? And then what's the role of the worker going to be in that? And I think we're going to see a transition. I think there are certain functions that are going to get more automated for worker safety, for worker productivity. We don't want worker fatigue. So I think we need to create a really good environment for the worker on the shop floor, but one that's flexible. And I mean, the fact is, go talk to, I used to work a lot with Japanese manufacturers. And for them, you have to go to the spot. You don't do this remote. Right? Get to the shop floor and understand.
Go to the Genba.
Yeah, exactly.
Yeah.
Exactly. And so the insights you can gain from that worker. The thing is, though, before you would then go set up a team, do some discovery, go pull data. That could take weeks. It doesn't take weeks anymore. I can interact with the machine with voice. The data all comes to me on whatever device it needs to come to me, and I can solve that problem much more real time. I think those are the opportunities that we have in manufacturing here.
Del, we've seen a tremendous evolution of the supplier industry over the last decades. And I'm more interested in your part of the supplier industry, because you mentioned earlier, Siemens bought Altair, paid a good chunk of money to get it.
A little bit.
Also, I want to say it's Ansys and Synopsys got together. We're seeing engineering and industrial services company going out and acquiring simulation companies. Talk about that evolution that's going on. What's driving it, and where do you see it going?
It's interesting because right now the explosion of data centers. I mean, what's the most limiting factor to AI? The ability to build data centers. What's the limiting factor to that? Where are you going to get your energy from? So this is all a system, And we talk about the Altair acquisition. The acquisition that fascinates me is, and when it happened, is when we acquired Mentor Graphics. And there were a lot of questions. Why would you guys acquire Mentor Graphics? We had Caliber, which validates the chip itself. And at that point, it was so different, right? The chip wasn't even part of the conversation. That's just something you purchased. Mm-hmm. Boy, look how we've learned from that point. So, and then you see Synopsys and Ansys. So I feel like Siemens was onto something back then, and how that chip interacts with the performance of the vehicle, and now the importance of that's going to play in AI, I think was a fascinating strategic move from Siemens. And it's so accentuated today because the impact of the chip, how you stack chips, the heat generated from the chips, whether it's in a product or in a data center, it's amazing the parallels in this. And we talk about AI factory. I look at an AI factory and I look at the parallels to a modern production or manufacturing environment. The challenges are different, but I have in a liquid cooled data center, I have the flow of something. I have potential power surge issues that I got to deal with. In a factory, I've got flow of product. And so how we solve those things and take trained digital twin models and have them at the edge so I can make a decision quickly. And I think that's one of the great things about working for a company like Siemens is that our world isn't 3D geometry by itself. It's not system model by itself. It's not flow down of requirements. It's the whole digital thread, but it's also production. We have hundreds of plants. We have World Economic Forum lighthouse facilities. We have these things. We've applied this technology. We've implemented it. We experiment with it like every other company or customer of ours does. So, John, I think that was a fascinating thing we did years ago. And it really opened our eyes to what it means to combine mechanical, electrical electronics, and software together. And so when you talk about a software-defined vehicle, there's different levels of understanding the impact of what that system model needs to behave like. And I think those are going to give us the future advancements in working with the supply base as well.
Mm-hmm. Yeah, I'm wondering, I know this is I'm kind of forcing you to oversimplify something that seems fairly complex, but I wonder if you can talk about sort of the buckets of where this technology has potential to, cut costs or cut defects or, and basically speed things up. Because it seems like the ultimate challenge that the Western automakers have, the Detroit automakers have, is if they're going to have, and I think we'll talk about this a little later, if they're going to have to, build in America for America at American labor rates, fine, great, but that's going to put pressure on their businesses and on their margins. So if you come with your technology, what are some of the buckets where your technology can save money? Is it in more rapid identification of problems that are causing warranty cost? Is it in cutting time and cost out of the upfront engineering and supply chain management? So we can talk about
I'm going to answer yes to whatever scenario you're going.
Okay. I keep going.
Because if you think about what I laid out, the answer is yes to that. Where I think it gets fascinating is combine. Again, I always look at AI from two lenses. I think there's so much potential and promise, and I think there's things we have to be very careful about, and we have to be super pragmatic. And if I pull the proverbial thread on that, I think an amazing equalizer for companies is how can they implement agents effectively? Because right now it's super expensive. You go consume a bunch of AI tokens, you wake up, you have a bill you didn't anticipate at the end of each month. I think that's gonna level itself out like everything does. And so if I deploy agents, what's my approach for deploying agents? Because that's kind of, I don't want to call it an infinite pool of labor, but it's a great supplement to labor force. Picture the scenario we talked about earlier with running all these simulation iterations where we could run a handful before, now we can run thousands and we could triangulate on really good results. That's amazing impact to time to market and cost savings. If I have issues in the field and I have a robust, comprehensive digital twin of my product and my process and my ability to service, when those issues come up, I can explore all the reasons for that. I can use AI and agents to help me do that. Again, engineer in the loop, but I have that opportunity to process data like never before. My insights are off the charts. That's the promise. That can really equalize things in terms of cost base. Done right. But you have to have the investment now in that foundation. Because if I have data sitting all over the place and it's not contextualized, how am I going to come to the right conclusion? We all know the AI output is going to be, it's probabilistic, it's going to learn off models, it's going to learn off data. If that isn't complete, what I'm going to get out of it's not going to be. So those are the opportunities, I think, for global manufacturers. It's how far can they what steps are they taking right now to make sure they're prepared to get the benefits out of it?
You talked a little bit about the difference between OEMs and suppliers and smaller companies' adoption rates. What about globally? Where does the U.S. stack up in terms of adoption and implementation? Also, are there any regulatory concerns or IP?
Yeah, things are going to move so fast. I don't know. You guys are experts in the field. You talk to all the industry leaders. The IP thing is an interesting one for me, just with how pervasive information is and how fast things move. What are you going to be? What's going to be your most important IP of the future? That's a difficult question for me, honestly. Just being in the technology sector and seeing how fast things are moving, I'm curious how that goes. As far as adoption goes, we see pretty incredible adoption all over the place, and you look at it across industries. Automotive has been one of the pioneers in digital technologies. I mean, again, we can go back to I throw out some names, but I'm sure you remember Frankie was issuing his Factory of the Future and Digital Factory Initiative.
In fact, I want to say the first CAD CAM used just about in the world was General Motors in the 1960s. Very basic compared to today, right? But it was a pioneer.
They contracted really the first modern PLC, and that was a project done for General Motors. And Siemens had been in that business in Europe in the 50s and 60s. So you look at that first PLC in the early 70s, it was really implemented for General Motors. So you look at the innovations that really were here in the automotive industry in this town. But you look across industry sectors, I think you look at industry sectors as much as anything in terms of globally, because there's advancements all over the world. There are companies that lean in all over the world. There's startups that are doing absolutely amazing things with technology. Heck, on stage at Realize Live, I mean, you saw some of the advancements happening in rockets right now for the purpose of launching satellites to handle communication. And so we're seeing just incredible innovation based on industry need as much as we are geographically.
I think NASA was one of the first to implement a digital twin back in the late 90s or so.
Yeah, you watch what we get to a close seat with SpaceX as well. So it's fascinating to watch.
That's a good point. I mean, we think about the auto industry all the time, but honestly, it seems like cutting edge in manufacturing is not necessarily the auto industry. I mean, it's the chip fab industry, right? Or maybe it's, as you said, SpaceX and the space industry. I think you mentioned, the energy industry. I mean, they're so that this is kind of proliferating everywhere.
I got to tell you, I spent Monday and Tuesday with a company in Texas, and I was blown away. We often get asked, what does it take to deploy successfully? And the very senior executive there, they're doing a full transformation of their organization, structural. They're partnering with us on a key tenet of that to enable this transformation that they want to do. And they're going to look at their business differently going forward. And they want this to be the foundation of how they're going to carefully grow with AI. And he looked at me and he said, you guys implemented, against our will, we worked with you on a process that you told us we need to do to run this project. And I got to thank you for that. He goes, but I got to tell you, one of the things, because we were struggling for a couple of years when we were trying to get this project off the ground, he said, one of the things that you proactively did with us that I think was game changer is you educated us, all the constituents, senior, mid-level, users of the system. He goes, you educated us on the capability that the system has. I walked out of there. It's interesting. You can hear something at different decades of your career and it means something completely different. For me, at this stage of my career, that was so profound to hear, because I think as leaders and folks in the industry with a lot of experience, we have to humble ourselves a bit to recognize it's too easy to make decisions and say, team, go do this. But as a leader, if you don't invest in the details, and I think it's more important now than ever with AI, because if you're making a decision and you don't know the pros, the cons, the risks of AI, and you're not participating in the leadership of that initiative, we as your partner can't save that. We can advise, we can recommend, we can push. But trust me, I've been involved enough that we come in and what we're doing, we're replicating an existing process, absent what the new capabilities will bring. Well, that's going to accelerate more than ever before in my career. AI is going to change things very quickly. Interaction models in these systems. If we look at the way we've done it before, I don't know that that's the right thing. We have to look at things. It's kind of like the conversation we were having on form and function of a robot on the shop floor. Does it need to look like a human? It probably doesn't. It needs to match the function it needs to do. I think technology is very much going to be that way as it continues to evolve. So I'm really pumped at what the next couple of years are.
How fast is AI progressing? We used to have Moore's Law. Is this an accelerated version right now?
I think it's an accelerated version, but again, I think we have to be very careful. It has to fit into what we do, and we have to constantly ensure that what we're getting out of AI is foundation to what we need out of AI. Again, if I'm on the production floor, I can't ask a question of a system and get different answers. I need a precise answer. I need to discover where that quality issue came from. If I have a throughput issue, I need to discover why. I need to get to root cause fast. But it needs to be, it can't be a thesis. It's got to be something that's proven. And so I think that's going to be the key. So I think it's going to change extremely fast. But I still think we have to be smart about how we adopt and weave it into what we're doing.
And Del, with that, we're going to have to wrap up the segment of the show.
Oh, that went quick.
I know, it really does, especially when we're so engaged in the conversation like this. But thanks so much for coming on. And, this digital world is fantastic, and very intrigued by what you're saying about how AI is even going to accelerate it.
Thank you. This was a lot of fun.
Real good. We'll be back in just a moment to talk even more about what's going on in this crazy industry.
We act, we grow, we transform, we protect, we rescue. In moments that define the future, we are the partner you can trust. AlixPartners, when it really matters.
Knowing that a little rain won't slow down your day. That's what really matters. Bridgestone Turanza Quiet Track tires. Confident control in wet conditions.
We're back, and now we've got Mark Wakefield, and I got to read this because I can't keep this memorized. He's the global automotive lead executive,
title, yeah.
Partner and managing director for AlixPartners.
Yeah, executive partner is a new title that they gave about 8 of us. Yeah.
That's great.
Yeah.
And Mark, you guys just presented yesterday your annual global update for the automotive industry, and there's some hair-raising stuff.
I was going to say, what a basket of cheer that was.
There was some positive. We're higher than S&P on our forecast, for one thing. That should be a rising tide. But we do it each year where we get all of the team from around the world, say, okay, what'd you work on that was neat last year? Let's sanitize and synthesize this. Let's get all on the same page internally. And then there's some of that stuff that's able to be shared publicly. And so we do it in that process.
Well, what I like is how comprehensive it is. I mean, you go all through the world and you hit so many different topics on it. And we can't possibly talk about them all in the segment that we've got on today's show. But one thing I wanted to get into that really stood out for me is you're advocating for what you're calling Fortress North America, not just Fortress America, but North America. Take it from there.
Yeah, I mean, it starts with almost being crazy that we're doing projects to help suppliers and automakers figure out the compliance. And when I mean the compliance, I don't just mean actually how to comply on the tariff. I mean like the administrative pieces of it. It's a real cost, actually. It's like 1% to 2% of the cost of a vehicle.
$2,000 a vehicle.
Almost that. Yeah, almost that. And so, if this gets worse with a USMCA 2 that's very focused on origin, on tracing, and it's tracing across Mexico and Canada and the US, this is going to get uglier compared to the real focus, which should be China. A competitive and resilient North America facing off against China. You have just a natural logic to it where you've got, first of all, the supply chain and the value chain is already built that way. The market is dominated by the U.S., so there's not really a fear that the U.S. gets elbowed out of anything in this mixture. But you've got things like 15 million tons of REE oxides ready up there in Canada. You've got processing facilities in Alberta and Saskatchewan coming online for those. You've got hydropower and aluminum in Quebec. So they're not really at risk of becoming the next AI chip locator. But you combine that, the labor of Mexico, the infrastructure that's built up in Mexico, and you have fairly compliant then Mexican and Canadian governments supporting this idea of, hey, let's all get this together and work better. You then had, if you had the governments and the industry doing like a Semitech style collaborations around the ADAS and AV chipsets that are required, the kind of technology that has to go on the vehicle, you now have, instead of dealing with these sort of trade things on the continent, you're dealing with things that matter in terms of getting up to speed to prepare for the Chinese coming here, or the Chinese basically leapfrogging elsewhere, and this being an isolated market. So it to me, it makes a ton of sense. To me, it also, you've got these 232 tariffs that are putting billions into the Treasury's bank. Why don't we use some of that money to invest back in making the industry actually more competitive on a carrot, not just a stick? And then we also, the benefit of that is over time, that becomes a lower priced car for the consumers instead of just a tariff that becomes a higher priced car. Because there's a lot of stranded capital that will come from moving plants 100 miles south from Canada or 100 miles north from Mexico.
No, that does seem like the problem. I mean, you mentioned the compliance costs and sort of the costs of ripping up the existing kind of state of play in North America. You talked about something else, though, which seems like it's going to happen whether this vision of what should happen in North America goes forward or doesn't, which is that the automakers are becoming more regional. The idea of, build it once, sell it everywhere, which I started with in this, and probably you did too.
Yeah. That's
gone, right? I mean, and I think you talked about the automakers, if they want to have any global presence at all, I think even outside of China, there's going to have to be like a U.S. product with U.S. tech, U.S. spec, and then everywhere else. Talk about some more about that, because that seems like another drag on the industry's.
Well, that's a drag, but that does fit to a degree, because you're trying to prevent and give a protected period for the U.S. industry to catch up and to change. That obviously can't be too long. I said I think that's around 5 years. This is probably an appropriate time period to do it in. But that does mean that if you're doing all of these origin and you focus it on China to look for Chinese tier 2, tier 3 raw materials, Chinese software and hardware, then it's really just focused there, and it's an easier process than checking, this thing moved from Poland to the Czech Republic, then to Germany, then to the US, down to Mexico, and back up to that. That's not very valuable, that exercise, compared to, did it come from China, or is it involved with China as an foreign entity of concern type of affair. That still is likely needed to prevent everything just being Chinese oriented and Chinese sourced and related. So that's sort of a necessary evil compared to the U.S. and Mexico orientation of trying to push the scales there, and it distracts us from the real mission, which is getting a healthy, fit, competitive industry that can take on the Chinese industry in 5 years.
I was just at a conference, and one of the keynote speakers was the head of the critical minerals division of the DOE, which I didn't know existed until I saw him speak. But he was talking about bringing back or finding alternatives to both rare earths and other critical minerals for batteries. How critical is that, and what kind of progress is being made, and how long it will take to really implement that?
I mean, it's very critical, but the reason I talk about this sort of Semitech thing is that doing it with 20 different players doing it, between tier ones, battery companies, and OEMs, versus doing it as a pre-competitive base that then is able to be used by people that participated in that are US based, makes it much easier to go through and do that.
When you say pre-competitive, you mean but basically the governments should do it?
Yeah, like Semitech was this thing where 50-50 industry and government to put in. They did, think of AV training, even beyond the hard things of chips. Think of like how hard it is to get good quality AV training data, right? And you've got all these automakers that are putting chipsets, sensors, cameras, things on the vehicle that aren't even used to help the customer now, They're there to get training data and be able to do L2++, L3, and stuff.
And they're all duplicating.
And they're all
each other.
duplicating.
Yeah.
Right. And their efforts each are subscale to what you really need to do the analysis, right?
Yeah, and they're not going to come together and just use one model and one thing. But the pre-competitive thing is the nature of this data lake of having all of this training data available for the participating groups. That's an example.
Yeah, that makes, I mean, it makes so much sense. And yet, right? And yet it's
Not
not.
the focus is on, is it 50% US content or 82.5?
Yeah, no, I think you really touched on something here, that if we treated North America as a united supply chain, we have a much better chance of competing with the Chinese. And also, this whole idea of using, like you say, the natural resources and the cheap energy that Canada has, and the cheap labor that Mexico has. But
You just said the magic words, though. Cheap labor. I mean, that's the thing. And it seems like the sort of the elephant, there's a bunch of them, but one of the elephants in the room here is the labor arbitrage with Mexico.
Yeah.
For the United States, and I imagine for the Canadian unions and Canadian workers too, that's the problem.
It is and it isn't. Don't think of it as a labor arbitrage of the US to Mexico. Think of it as a labor arbitrage between Mexico and China.
Okay.
And then it's a different story.
right.
And if you look at the trends on employment, the productivity, the robotics, putting a higher bar on things has driven more robotics to one degree. But the import data, it's Canada that's actually through NAFTA, the one that got hurt a lot. China's now flatlined for about the last 10 years in auto imports. So the idea of the BCC is now, or LCC is now BCC and not China for best cost country sourcing. But Mexico's still going up, Canada's still going down. So it's really the Canadian group that's got hurt in terms of employment more so than the
Which
US.
is why
group.
they're playing their China card.
Yeah, but you think of the China card is already being played. There's 40 plus supplier plants in Mexico, and half of them are new plants that got put up in Mexico. So if you had a united front that said, no, we don't want this, we want X, Y, and Z, and it was a consistent industrial policy across North America, you would have a lot easier time doing the wins to fight the next war instead of trying to sort of hold on to today.
And so what you're saying, instead, what we're getting in terms of compliance is a bunch more red tape and bureaucracy sprinkled with tariffs.
And sort of stranded capital where you're having to move stuff for convenience. There's a whole bunch of, don't get me wrong, there's a whole bunch of loopholes that need to be fixed. If things like when you get a part that comes in at 76% from Canada, 76% Canadian, but it's got 24% Chinese, and it becomes magically 100% USMCA compliant, that's the kind of loophole that needs to get closed, and some of these other sort of transshipping types of things. But, and that's going to be tough. The compliance cost will be there for real. But let's focus the cost on achieving the goals that we really want rather than.
So Mark, you talked about
minor
a five-year window.
Yeah.
And I guess I want to kind of press on that a little bit because we talked about this at one of the conferences that we've seen each other at in the last month. I mean, given the reality of the state of the supply chain, is 5 years enough to basically relocate the supply chain for the North American auto industry out of China? Yeah. I mean, you can't even make the dies, right, that we need in this country without China. So, I mean, how much can we do without China? How fast is it going to take to really become regionally self-sufficient?
Yeah. I mean, I speak of that more in the sense of getting competitive on an electric vehicle and on ADAS and AV and on an SDV. And no, I don't think you're competitive by then, but I think if you go too much beyond then, there's not the impetus to move. And some of these things, the processing, raw material processing is a 10-year affair to get a new pipeline. So that's not in 5 years, but it has to be started and moved along. And it also feels like if you try to hold the line too much, there'll be creative solutions around it. And
Well, as we're seeing in Canada, essentially.
Yeah, in Canada, but also, some other licensing things, some other different backdoors that you're already seeing the safe harbor things against ICTS and these other creative solutions around the laws. And yeah, new laws can be put up. No Goshen law is clear as day is what that's about, right? And but it's hard to hold that line against economic gravity, economic weight of if there's a better mousetrap, not using that mousetrap. So it's about trying to get to a competitive mousetrap.
So you move away from China. What will the role of nearshoring, friendshoring, and areas of expertise for other countries play in the whole fortress strategy?
Well, one of the things you were mentioning was this idea of this sort of fourth era of globalization. We had a globalization window that was in the beginning, then into the Depression and the sort of different protectionism things that took it down. And then after World War II, the starting of globalization, a whole bunch of things that sort of moved it towards standard, even containers, shipping containers, and not all of it was laws, right? Mm-hmm. And you had a growing globalization dramatically through to, about the mid-2000s. And then it kind of flatlined from there. And you've seen more and more regionalization, difficulty with crises that expose supply chains across the water, difficult with politics, difficult and different regulations and sort of non-industrial logic regulations coming in that disrupt a plan that was put in place. That's going to happen more, not less. So we now no longer have a U.S. hegemony. There's the Pax Americana, all this stuff is yesterday's news, right? It's now a China and U.S. Not equal, but there's two main parties here now.
Well, honestly, when it comes to the auto industry, China is ahead.
Sure, I'm talking, I guess, more global.
Global, I say geopolitically.
And in some ways, they're not, even in auto. But the point is, it's not like a U.S. hegemony that works as a globalization. So in that, you then pick your zone, and you can pick North America fairly straightforwardly. It's a lot harder to do Australia or to do a Japan or a Korea connection in, because there's a lot of things that could happen politically with how that moves, also in economics with how that moves. So the North America, it's not going anywhere, right? And it's not an area where you're worried about a significant influence on Canada or Mexico from China.
Mm-hmm. So, as I said, you guys covered a lot of topics in your latest report. One that truly intrigued me, and this is getting away from what we were just talking about, is you. No, it was really good. But man, I wish we could go on another 2 hours. But what you brought up yesterday is that over-the-air updates, OTAs, might become obsolete. And
yeah. I didn't mean obsolete in that way, because it's still you're talking about the AI DV.
Self-healing.
Yeah. So you get self-healing. So right now there's a lot of bug fixes that go on in OTAs. And it's a frustration because, you want new features in the car as a customer. It's kind of nice that something's irritating you is fixed, but wouldn't it be better if the car fixed itself? And you notice something wrong, even if you had to press a button and say, I noticed this, I didn't like it, and the car then tries to fix that thing to the degree it can, right? So not into the source code, but just into like a driver monitoring layer and a driver feature layer that configures things instead of really adjusting source code. The source code, of course, has to get homologation tested. And then the OTAs still happen a lot because you still have then that vehicle saying, hey, I fixed this thing. Anybody else want this fixed kind of thing? Some things coming off a vehicle instead of a one-way OTA. And then you're still going to have OTAs for feature updates and for other things that have to go through a homologation process and safety pieces. So it doesn't really take away from the OTAs, but it makes them not this process of the only way to update the vehicle, and sometimes a very frustrating way, because especially with the vehicles today, there's a lot of ones that are having a very tough time, especially in the US, doing OTAs because of the amount of compute power and the amount of battery drain required to do them. You can't even get them done sometimes overnight. And so the ability right now, they're trying to do jump state OTAs where if you're in version 1, but you need to go all the way to version 5, you can just jump there. Most of them aren't built that way. They have to go 1, 2, 3, 4, 5 to get to these updates. So it's a real bottleneck that's not really pleasing customers at the moment because it's not bringing in the new features. Tesla probably does it the best in terms of having the goodwill of their customers. Most others don't really have that goodwill, that sort of, oh, good, I get a new feature coming. And so having the AI pieces take care of that, most of those issues could be dealt with if you did have a central compute and an SDV, but then you had AI layers on that in configurations and in being able to learn what's happening and adjust the vehicle without needing to go off. You still need some good edge compute, very strong compute. You also need some cloud, and so there is OTAs, but it's just not in the way that it is today.
So is there anyone doing that? Or
No. This is like 5 years from now.
So this is projected.
Yeah, I mean, you're kind of seeing a bit of it in IVI in China, but not much, I would say. So this is more, people are still working to get to SDVs. They're not having the compute on the car enough to do this yet. This is probably 5 years away.
Any examples of the types of features and functions where this, I imagine there would have to be limitations regarding safety and.
I mean, ADAS is an obvious one, but that if you can correct an error or a problem, then that's a benefit, right?
I would think almost any kind of software glitch.
Yeah, glitches and bugs. Like if you're fixing something that's not working and it also then doesn't work, like, okay, it hasn't worked. But you can also, that's why I'm saying it doesn't go really into the source code. It's into a configuration layer effectively. So it's not doing something that would break homologation rules or something like that. But there's a significant amount. I mean, honestly, you've had learning transmissions and other things that do a bit of machine learning for many years into it. This is taking that to a bigger layer. Now that you have the connectivity into all actuators, you have data coming off the vehicle, and you have a much higher preponderance of bugs that you need to fix. And you can then have, instead of half the engineers working on bug fixes, you can have them working on true feature enhancement and do the more routine bug fix is handled automatically on vehicle.
Yeah, J.D. Power was out today with their initial quality survey, and Ford managed to kind of get to the top in the mass market. Good for them. But I was reading the rest of the report was interesting. Is infotainment is still like the number one dissatisfier. It's been that way for years. It's kind of like it seems like that's like elementary school in terms of the stuff you're talking about, and yet it seems like the industry is struggling with that.
Yeah. Struggling with it in part because it's on old architectures, electronic architectures, that are just difficult to deal with that. But yes, absolutely. And then the speed of which something gets fixed. Like if you've got to wait weeks for something to get fixed, it's not IVI, but in like a recall type element, versus if it sees it and fixes it itself, that's a dramatic difference of a customer experience. And you do risk this thing of these OTAs not being seen as positive and being eventually seen as a nuisance and negative, and especially when you're then going to be competing, you say in 5 years' time, you've got something that does do this and something that doesn't. Now this thing, it looks like a Nokia to an iPhone type of thing.
Yeah, for sure. I mean, and that seems like, back to the first part of our conversation, that seems like a big risk for some of the legacy automakers is that you'll increasingly have a situation where people know that there's, the product that's up here and kind of doing the stuff that you're talking about, the digital tricks and not tricks, but digital enhancement, all this cool stuff. And then, it's the rest of us are living in some version of Havana and, with old tech that doesn't update. It just seems like that's a real competitive problem.
It is for anyone that has a big fleet of portfolios to deal with, but this is where it's like on the SDVs and like on the electrical architectures that need a clean slate jump to be done. You're going to need basically a clean slate jump on this as well. And so if you have the cash flows that the U.S. automakers are having, you have the ability to do that. And it's better to be started on the next war than fighting today's war. And frankly, a company like a Tesla is very well positioned to be one of the first to do this. And then it's in your backyard and you're seeing what it's doing, and it's not to say that it will obviously be a Chinese that does this first.
Yeah, that's true. Yeah, we shouldn't forget about Tesla.
Okay, another big topic jump here, because one of the other things that you guys have uncovered, this now jumps to Germany with young Germans. And what I found intriguing is young Germans aspire to Chinese automotive brands, not German ones.
Yeah, the avoidance. So what we find is hard in surveys. It's hard to deduce the truth. If you say, do you prefer this or you prefer that? What's better is to say, what do you not want? And then you look at how many people avoid this, basically. So you can look at it two ways. You can look at the ones like, you can say, okay, do I have champions that are advocates, the 9 and 10s? And yes, that's a worthwhile signal. But parsing that specifically when you're asking about things people haven't experienced yet is a very difficult thing to put a lot of faith in. So what we asked is, one of the many questions we asked in the surveys was, what would you not buy? What are you for sure not going to buy? What would you avoid buying? A car from which region? US, China, and you could choose more than one. And yeah, the young Germans below 35 had a higher avoidance on German cars than on Chinese cars, showing why you see excitement of BYD and others to go into Germany and to make a shot at it. And by the way, the avoidance wasn't very high in the US either.
In fact, I think you found that only 25% of Americans would not buy
Young
a
Americans,
Chinese car under any circumstance, which means 75% are open to the idea.
Yeah, the 20 of the 34 and below age. Yeah,
And by the way, in 1975, if you did that survey about Japanese cars, you might have found some of the same, maybe even worse for the. And then, where are we?
Yeah, I mean, the older population, it's not like that, right? It's as you would expect. But in the younger population, that's what we showed. And that bodes poorly for the Germans, and it frankly bodes poorly for the US in terms of just an open competition.
So all or mostly electric vehicles on the Chinese side that
We didn't ask about electric versus ICE, and frankly, there's both being imported into Europe.
and do you think it's tied to cost?
Definitely kind of to cost, because that's one of the things when we looked at, it's not just the sort of tech and these specs. There's an expectation that the Chinese car is cheaper, for a like that it's cheaper. There was also expectation, though, that it was more modern and had more technology in it. So that's also, to a degree, a nature of cheapness, right? Of putting features in and not charging for them, in addition to actually having a like that is less expensive. There's an expectation of that. But that expectation is also a reality.
To Joe's point, have you asked this question before to see what the change has been?
We didn't ask this question this way. We've done, the other stuff was more oriented, the prior stuff was more oriented on electric vehicles and electric vehicle readiness. And as that was kind of flatlining, we looked more broadly, in part because of just how much of a existential threat it is, the Chinese coming into Europe. Like, everybody else is kind of shrinking, and the Chinese are the only ones growing in a market that's fairly flat. So that was the impetus, the idea of, is this going to work, and who's going to buy these? Why are they going to buy these? And what can both players do around it?
Mark, as you know, a lot of people watch the show who work in the industry. They're probably going, hey, what else is in this report? How can they get it, or can they get it?
So it's not like a printed report. It's the repository that our team gets through, so we all sort of know what each other know, and then we can then share on various topics. So you can see on our website a list of those topics. They can reach out to us. We're happy to talk through 2 or 3 of the things that are most important to them. We don't publish, thousands and thousands of pages of things. It's more built for us to do our work with clients, but it does have relevance for people in various topics.
Yeah, well, good. With that, we're going to have to wrap up the show. Thanks for coming back on again. You know we're going to have you back. I mean, you've been on for years now, and it's been great.
That's my pleasure. It's great fun every time. Thank you.
Yeah, great.
Steve Plumb, thanks for joining us. And Joe,
you.
always good to have you here, too.
Great to be here.
And I want to thank all of you for having tuned in.
AutoLine After Hours is brought to you by AlixPartners. For more than 40 years, we have helped companies and their stakeholders around the world harness opportunity, overcome challenges, and achieve outsized outcomes. AlixPartners, when it really matters. And by Bridgestone Tires, solutions for your journey.